So the special idea of Ricas is to produce a battery which is situated underground. Why to place it underground? On the one hand side, we have to take care on landscape issues. So if we would produce steel constructions on above ground, nobody would like to see that. So we are having a lot of underground structures available, and what the principal idea was to use these existing underground structures, but to be completely independent from the geological conditions.
What is happening is that we use surplus electricity to compress ambient air, and the heated air that is generated by the compression then goes through a thermal storage unit,
which is called in the short form TESS. This TESS is a kind of boiler, is a kind of storage what everybody has at home. Normally you use it by water. We are intending to use no water, we are intending to use a gravel. The kind of gravel is not fixed yet, but is the intention to find out what is the best. So we could use glass bores, we could use ceramics, we could use also tunnel excavation material for that.
And then when we want to generate electricity again, the cooled air flows out of this cavern into the thermal storage. It takes up thermal energy, and then it is expanded in a turbine that drives a generator.
The problem is we produce a lot of pressure then. If we are producing a 5 megawatt powerhouse, then we are producing a 36 bars, which is a pressure which we are not used to do in underground structures. Normally if we do energy production underground, we normally do it by hydropower. But this time we do it by compressed air. So we have to find a ceiling in the tunnel which is safe enough to keep these 36 bars really in the tunnel. We first have to find a solution how to take the rock pressure. In the Ricas, our big challenge is to be completely independent from the geotechnical conditions. So Erzberg, here Zentrum am Berg, is a perfect location to train that, because we have good rock conditions, bad rock conditions, and what we are doing here is to find solutions, economic solutions for the first outer lining, consisting of the shotcrete, the wire mesh and the arches. After we have finalized the outer lining, consisting of shotcrete, wire mesh and also arches, we are now intending to take the pressure by segmental linings. Segmental linings in tunnels are always built in parts. Normally if you have a 10 meter diameter underground structure, you need 7 parts, which we call segmental linings. And now the big challenge is to take the pressure which is produced by the compressed air between the segmental linings, because they have ceilings around, so they can take a certain pressure, so in the range of 5 bar, 7 bar in this region. But we need more. And now our big issue in research is how can we take more pressure by the segmental linings, highly reinforced, which are already here, and let's say a soft shell in between the outer lining, which takes the rock pressure, and the inner lining consisting of segmental linings. So what we are intending to do is to use conveyor belt materials which have a high tension capability but also elasticity. I think we will proceed with this idea and find the solution on that. We would like to run this powerhouse 1 time a day, which means we blow it up during the day, and we use the energy of this underground structure during the evening hours. So on the next day, again, we have this circle, and this is a complete new, let's say, load case for underground structures. And the intention is to find out linings which are independent from the geological conditions, so that we can, let's say, set these powerhouses also in Mumbai, in Delhi, where we have quite, let's say, or Shanghai, where we have quite, let's say, poor ground conditions. Of course, it would be easier to place it in Norway, where we have high massive granites. But the intention is to make the development completely independent from the geological conditions. So these are the main features which we are studying.